Hi everyone, you are welcome to this session. In this session, we will be looking at equivalent fractions. Equivalent fractions. The last time we talked about types of fractions, proper fractions, improper and mixed. Now let us look at equivalent fraction. What does the term equivalent signifies? Equivalent, equivalent, equal. Yes, that's what the word equivalent signifies. So when you hear the word equivalent fractions are fractions that represent the same part of a whole number. Yes. Equivalent fraction. Remember I told you fraction means part. So when I say equivalent fraction, it means equal parts. So these fractions has different denominators, different numerators, but they still represent the same part. For example, 1 out of 2 is a fraction. 2 out of 4 is another fraction. 3 out of 6 is another fraction. You discover that all these fractions, they all have different numerator at the top. And they also have different denominators underneath, but they all represent the same part of a whole number. For example, if I give you 1 out of 2, what have I given you? I have given you half. If I have, let's say, a box of chocolate, I divided it into 2, and I give you 1 out of 2. I also take 1 out of 2. This is half, right? So 1 out of 2 is what? 1 out of 2 is half. 1 out of 2 is half. The same thing in this 2 out of 4. If I should divide the same box of chocolates into 4 places, and I give you 2 out of the 4, that means I'm giving you this 2 out of all the 4. 1, 2, 3, 4. So I'm giving you 2 out of the 4. You discover that what I've given you is still half. The same thing if I divide it into 6 and I give you 3 out of 6, I have still given you half. So you discover that all these fractions are equivalent to half. If I should give you 5 out of 10, it's also half. 10 out of 20 is still half. 3 out of 6 is half. 4 out of 8 is half. So all these fractions will still tell you that they are all equivalent. This is also one of the reasons I recommend using out of, because you will easily understand what equivalent fraction means. So taking 1 out of 2 is half, 2 out of 4 is still half, 3 out of 6 is still half. This is what equivalent fractions mean, which means we can have so many equivalent fractions and we can always take half out of it. Remember I told you that fraction is an English word. So we can have so many equivalent fractions and we can always get half from it. So half has different forms in its mathematics representation. So you can write half as 3 over 6 is half. You can write half as 20 out of 40. Yes, you can write half in any way you want to write it. Just make sure that it's half. The number at the top is half of the number at the bottom. That is what half means. Now, how do we get equivalent fractions? How does these equivalent fractions come out? There are two different ways to get equivalent fractions. Yes, there are two different ways we get equivalent fraction. The first one is by use of multiplication. We call this form the expanding form. And we have another method where we get equivalent fraction by use of division, and we call this the reduction form. So let's take it one after the other. Let's say we have a fraction 2 out of 4, and we know 2 out of 4 is half, right? Half. 2 out of 4 is half. How do we get the equivalent fraction by use of multiplication? You are going to take a number that is not 0. Apart from 0, you can use any other number to multiply. You can decide to use 1, or you are going to get the same number. You can decide to use 2, 3, 4, 5, 6, 7, 8, whichever number you feel like, but you cannot use 0. If you use 0, you are going to get a 0 as a final answer. So we are going to be using any number to multiply these numbers. You use the same number to multiply both the numerator and the denominator for us to get an equivalent fraction. For example, let's take 2 for example. Let's use 2 to multiply. That means we are going to do 2 multiplied by 2 and what? 4 multiplied by 2. So we are going to use 2 to multiply the numerator and use 2 to multiply the denominator. You can see we use 2 to multiply the numerator and 2 to multiply the denominator. And then the answer we get is going to be what? 2 multiplied by 2, which is 4, out of 4 multiplied by 2, which is 8. And now 4 out of 8 is also half. Yes, 4, if you pick 4 out of 8, is also half. Let's say we use 3. Assuming we use 3 for the 2 out of 4, we are going to multiply both the numerator and the denominator by 3. Therefore, we are going to have 2 multiplied by 3 and 4 multiplied by 3. 2 multiplied by 3 gives us 6. 4 multiplied by 3 gives us 12. And you see that 6 out of 12 is also half. Yes, it's also a half. So we can get equivalent fractions by multiplying the numerator and the denominator by the same number. Don't multiply only the numerator. Don't multiply only the denominator. Multiply both the numerator and the denominator by the same number, like we've done here. So let's take one more example before we go to the reducing method. Let's say we still have 2 all over 4. Let's decide to use 5. Yes, let's use 5. Let's multiply 2 by 5 and 4 by 5. So we have 2 multiplied by 5 out of 4 multiplied by 5. You can use any number as I told you. So 2 multiplied by 5 is 10 and 4 multiplied by 5 is 20. You can also see that 10 out of 20 is also half. So this doesn't just work with half. It works with any fraction at all. So let's look at the division aspect where we have to reduce. In the division aspect, what we are doing is division. Instead of multiplication, we are going to be doing division. So in this case, we are going to divide both the numerator and the denominator with the same number. For example, let's say this is the fraction we were given, and we have to reduce it using this division. You can choose any number. You can decide to divide these numbers by 2. That means you are going to divide 4 divided by 2 out of 8 divided by 2. And when you do this, 4 divided by 2 is going to give you 2, and 8 divided by 2 is going to give you 4. You can see 2 out of 4 is still half. Yes, you can decide to use 4. 4 divided by 4 will give you 1. Okay? And 8 divided by 4 gives you 2. And you still get 1 out of 2. Let's say here, right now, we can decide to divide using, let me say, 2. That means we can have 6 divided by 2 and what? 12 divided by 2. 6 divided by 2 gives you 3 out of 12 divided by 2 gives you 6. And you see that 3 out of 6 is still half. So you can get equivalent fractions by either multiplying both the numerator and denominator with the same numbers, or you divide both the numerator and the denominator with the same number. So whichever one you are going to do, make sure you do it, whatever you do to the numerator, you do it to the denominator. If you want to multiply, you multiply both the numerator and the denominator. And if you want to divide, you divide both the numerator and the denominator. Now, when you see two fractions, how do you know if they are equivalent or not? Imagine I just gave you a fraction like this, and I said 2 all over 6. Is it equivalent to 4, let me say, out of 12? How do you know if they are equivalent or not? How do you know? You carry out what we call cross multiplication. Let me clean this. Yes, you can see two different fractions like this. How do you know if they are equivalent or not? You carry out what we call what? Cross multiplication, like this. I'm going to draw a cross from this number at the top here to this one, and this one to this one. And you are going to multiply in that manner. You are going to multiply 4 multiplied by 6, like this. 4 multiplied by 6, and what? 2 multiplied by 12. If the answers you get are the same, therefore they are equivalent fractions. But if the answer you get are different, then they are not equivalent. So let's check this. 4 multiplied by 6 is what? 24. And 12 multiplied by 2, 2 multiplied by 12 is also 24. Therefore, this fraction is what? Equivalent. You can see another fraction like this. Let me say 2 out of 5 is equivalent to 6 out of 15. For you to know if it is equivalent or not, you carry out cross multiplication. You carry out 6 times 5, and you carry out 2 times 15. If their answers are the same, therefore they are equivalent, they are the same, they are equal. 6 multiplied by 5 gives you 30, and 2 multiplied by 15 gives you 30. Therefore, this fraction is equivalent. What about this fraction when you see something like 2 out of 3 is equivalent to 4 out of 5? For you to know if it is true, you also do the same thing, cross multiplication. 4 multiplied by 3 and what? 2 multiplied by 5. Remember, it's going to be like cross. So 4 multiplied by 3 gives us 12, and 2 multiplied by 5 gives us 10. These are not the same. Therefore, this fraction is not equivalent. So they are only equivalent if you do the cross multiplication and the answers are the same, then they are equivalent. But if the answers are not the same, then they are not equivalent. So the first thing we talked about was what are equivalent fractions, and we say equivalent fractions are fractions that represent the same part of a whole number. Yes, the same part of a whole number, and you can generate equivalent fractions by either carrying out multiplication, multiplying both the numerator and the denominator with the same number apart from 0. And you can also do that by dividing both the numerator and the denominator also by the same number apart from 0. These are the major things we have talked about. And now, we now talked about how do you know if fractions are equivalent. How do you know if fractions are equivalent? This is how you know if fractions are equivalent. You just do cross multiplication. When you carry out cross multiplication, if the answers are the same, 30-30, then it's an equivalent fraction. But if the answers are different, then they are not equivalent fractions. Now, the next thing I want us to go into right now is how to reduce fractions to their lowest term. Alright, Let us look at reducing fractions to their lowest term. Yes, lowest term. What does lowest term mean? Remember, a single fraction has different forms of writing that fraction. Okay, the fraction is the English word and we can write it in numbers. And there are several numbers we can use to represent the fraction. For example, half. We can write half as 1 out of 2. We can write it as 2 out of 4, 3 out of 6, 4 out of 8, 5 out of 10, and all of that. But out of all these fractions, which one is in its lowest term? Which one has the smallest value? You see that the smallest one is this 1 out of 2. Okay, this is the least term of the fraction. It is the term of the fraction that has the smallest value of numbers. And also you can refer to it as the term of the fraction in which the numerator and the denominator does not have any common factor apart from 1 again. That is just a big term of explaining it. What you should understand is the smallest value of fraction is the lowest term. And remember, to get to this lowest term, you have to be dividing. When we are looking for equivalent fractions, there are two different methods I show you. I show you how we get it by expanding, by multiplying. And when you are multiplying, the number will be increasing. But when you are reducing by division, the number would be reducing. So this reducing fractions to its lowest term is telling you to be dividing, to be reducing it until you no longer able to reduce the fraction. For example, assuming what we gave you is 5 out of 10, we expect you to reduce this fraction until it gets to 1 out of 2. If you are given 4 out of 8, you have to reduce it until it gets to 1 out of 2. Whichever of the fraction you were given, you have to reduce it to get its lowest term. Now let's take examples on this so that you will see how we do it. There are two different methods of doing this. Let's say we have a number like, let me say 18, let me say 12 out of 18. Yes, 12 out of 18. And we are asked to reduce this fraction to its lowest term. The first method you can use to do this is by dividing by any possible number. Just keep looking for numbers that you can divide both of them by. Remember I told you, when you are reducing or expanding to get equivalent fraction, if you multiply the numerator, you must multiply the denominator. And if you divide the numerator, you must divide the denominator. So whatever you do to the numerator, you must do it to the denominator. Now, since we are doing reducing fraction, what we must do is division. So you are going to look for a number that can divide both of them. And one of that number is 2. 2 can divide this and 2 can divide this. So the first thing is to divide both of them by 2. By saying 12 divided by 2 out of 18 divided by 2. 12 divided by 2 we get 6. 18 divided by 2 we get 9. So is this the lowest term? Remember, if it is the lowest term, there will be no longer any number that can divide both of them without remainder. You won't be able to reduce these numbers again if it is the lowest term. So you are going to check. You are going to continue checking until they don't have any common factor again. So for now, let's check. Can 2 divide both of them? No. Can 3 divide both of them? Yes, of course. 3 can divide both of them. Therefore, we'll continue by saying 6 divided by 3 out of 9 divided by 3. So we'll continue dividing it until we can no longer divide both of them by the same number. So 6 divided by 3, we have 2. 9 divided by 3, we have 3. So we are still going to check. Can 2 divide both of them? No. Can 3 divide both of them? No. Therefore, we have gotten the lowest term. This is our answer. Why? Because we can no longer reduce this fraction to get another equivalent fraction. We can only multiply to get bigger fractions. So now, this is going to be our final answer. This is the first method of doing this. The second method is very easy and straightforward if you know your highest common factors. You just find the highest common factors and you divide it once. You don't need to divide it several times. For example, this is our question, 12 out of 18, and we are asked to reduce it to get to the lowest to its lowest term. You just go and look for the common factor, highest common factor of your 12 and your 18. Remember, there are two different ways of looking for highest common factors. You can either look for the factors individually by saying the factors of 12 are 1, 2, 3, 4, 6, and 12. And the factors of 18 are 1, 2, 3, 6, 9, and 18. And then you circle out the common factors as 2, 3, 6, and you say the highest common factor is 6. We have done this before. And you can also do it by use of what? Prime factorization, where I told you you have to factorize, you have to change the 12 to prime factors and the 18 to prime factors. So we have 2 multiplied by 6 here, if you remember, and we have 2 multiplied by 6 turns to 2 times 3, and here is for 12. The same thing in 18, we have 2 multiplied by 9, and we have 2 multiplied by 9 changes to 3 times 3, as 3 times 3 is 9. So what can we slash out? We can slash out 2. Can we slash out 2 again? No, but we can slash out 3. So that's 2 times 3. We can't slash out any other thing. So 2 times 3 is still 6. And now you see that the highest common factor is equal to 6. So in this second method, all you have to do is to look for the highest common factor. You can see I was in a rush, in a very good speed when I was dealing with this, because I believe that you must have known all this from our previous videos and all of that. So the highest common factor is 6. What you just do is you divide both of them with 6. That is 12 divided by 6 out of 18 divided by 6. And 12 divided by 6 is 2. 18 divided by 6 is 3. Are you seeing it? The same. So you can either use this first method where you will be dividing it step by step until you can no longer divide it, or you use this straightforward step where you just look for the highest common factor immediately and you divide to get your lowest term. So this is what I think you should know about equivalent fractions for now. I'm going to be seeing you in the next class. Bye.